Yes, let me share my screen as I let another person into class. If you're here for lesson 2.3, then you're in the right video. Here's our playlist for this week, just a portion of it, today and tomorrow's playlist. Yeah, I think that there is an elementary school, and I may be wrong, but the Falcon Elementary may not be having school. I'm not sure about that tomorrow, but we are. So we have a Monday, Tuesday, Wednesday, Thursday, and Friday assignment. So I'm here to get you through this slideshow right here for 2.3. Keep in mind that if you have fallen behind any at all this week, I have 3 videos of the last 3 assignments. So please take the time to watch those. Doesn't take longer than a class period because I recorded each one of these during this class period. So make it work for you. I haven't gone in lately and graded chapter 1. So I am very behind on your grading, as you can see, because now we're into chapter 2. So my intention today is get this slideshow completed, give you the information you need to get credit for today's examinations and explorations. I think we go back with this slideshow. There it comes. We go back into the article we were looking at yesterday in lesson 2.2, and we're going to focus in on a few guided questions. Lesson 2.3 of Earth's Changing Climate. Let's begin. Today, we're going to reread part of this article, Past Climate Changes on Earth. Now, we're only going to read the introduction and the section called Alligators in the Arctic, the Eocene Period. We're going to focus on the role of carbon dioxide and methane and how it played a part in the Eocene warming. So yesterday, I didn't highlight much on the cryogenian period because that was something I suspected we weren't going to focus on. I thought, and I think that my prediction was right, that we are looking for carbon dioxide and methane effects. So as we read this, we're going to look for information. We may already have it highlighted that helps answer our new question. How do carbon dioxide and methane affect energy entering or exiting the Earth system? So here is our link right here. Before I click that, I'm going to read what this says. And it says, go to the article. That's activity 2 in 2.3. Reread the introduction and the section, Alligators in the Arctic, the Eocene Period. Annotate information. Well, let's go back. Annotate information that helps you answer the investigation question on the previous slide. Now let's go back. How do carbon dioxide and methane affect energy? So that's what we're looking for as we read through the article, only really the first chapter of this article. Keep in mind, we should have our annotations there from yesterday. The annotations I make are kept in my library. The annotations you've made all through the whole year are all there in your library. So today we're going to reread part. As we read, think of the question, how do carbon carbon dioxide and methane affect energy entering or exiting? After you read, use your annotations to help you answer the 2 questions below the article. So you see there's a hand in button, and this is our evidence that we've gone and examined the theories that are in the first part of this article. Evidence shows that Earth is getting warmer. The global climate is changing right now. Did you know Earth's climate had also changed in the past? During some periods in Earth's 4.6 billion year history, Earth has been much warmer than it is now. During other periods, Earth has been much cooler. In every case, climate changes on Earth have to do with the amount of energy that enters Earth's system compared to the amount of energy that exits. Energy is always entering the Earth's system as light from the sun. This energy is absorbed by Earth's surface and warms the air near the surface. At the same time, energy is always exiting the Earth system, passing through the atmosphere and going out into space. When the energy entering and exiting are in balance, global average temperatures will stay the same. Average temperature keeps its stability as long as the amount of energy entering the system is equal to the amount of energy exiting the system. If either one changes, whether it's the energy entering or the energy exiting, the temperature changes too. In the past, when more energy entered than exited, the climate warmed. When less energy entered than exited, the climate cooled. Scientists study past climate changes to find out what might happen as Earth's climate changes, both now and in the future. So our focus now becomes on the role of carbon dioxide and methane. About 56 million years ago, Earth's temperature rose suddenly. Earth got so warm that water in places that were normally very cold or even frozen, such as places near the Arctic Circle, became warm. During the Eocene period, landscapes near the poles looked like swamps in Florida do today. Earth had no ice caps, and the water in the Arctic Ocean was warm enough for a pleasant swim. In fact, scientists have found fossils showing that alligators, which are warm water organisms, lived in the Arctic during the Eocene period. The global average temperature was about 16 degrees Celsius, or as we know better, 60.8 degrees Fahrenheit warmer than it is today. Oh, 60 degrees warmer than it is today. Wait, 60 degrees. The average global temperature was about 16 degrees Celsius, or 28.8 degrees Fahrenheit warmer than it is today. Maybe that's what it's trying to say here. They did a really poor job of that. Here is our answer. It's going to be somewhere in here. And look at this. This is it. You can see there's only one thing here talking about whatever caused the change. You see, they don't really know what really caused the change, but somehow is we know that the energy entering probably stayed the same. What we know about sunlight is steady. So something kept the energy from exiting. What could have changed this balance? Here it is. Here's the answer. One theory is that the amount of carbon dioxide in the atmosphere increased. Now that's the part where they lose touch as to exactly why. Perhaps because of volcanoes, perhaps because of an asteroid, who knows? But this part right here. So let's take this now and highlight it And can we make a copy of it? No, I think we might be able to. No, we're going to have to highlight it again and make a copy of it. So let's go back and forward. I hope your dragging skills are better than mine. I'll take this. I don't want to delete my note. I know what I'll do. I'll put another one here. There we go. And I'll copy that because we have a question below. When more energy enters than exits the Earth system, what happens to temperatures on Earth? I know exactly where to find that. We have that highlighted also. Here, do carbon dioxide and methane affect energy entering or exiting the Earth system? Let's put this in here and see. If carbon dioxide increased, the amount of energy coming into the system from the sun wouldn't have changed, because incoming sunlight passes right through carbon dioxide. However, carbon dioxide in the atmosphere stops some outgoing energy from leaving the Earth system. Because of this, an increase in carbon dioxide would mean less energy exiting the system and higher global temperatures. Gases that affect the Earth system in this way, such as carbon dioxide, are called greenhouse gases. So, do carbon monoxide and methane affect energy entering? And this is how. This is how. That's an important thing to know. Now, when energy enters, then exits, when more energy enters than exits, what happens to temperatures on Earth? Temperatures on Earth will increase, and let's find out why. Here is our evidence. I want to go back, put this back the way it was, because I have a note with it that reads, this is how greenhouse gases work. Great. Now, the increased temperature tells us that more energy was absorbed by Earth's surface during that time. The balance of energy entering and exiting the Earth system changed in such a way that more energy entered the system than exited. That is when more energy enters than exits, what happens to temperatures on Earth? Right there. So all of this, whatever caused the change, we'll highlight all of this. Whatever caused the change, and we'll copy that. Now, I highlighted over what I had highlighted before, but I should get a copy, and I do. Yay. We'll put that here. So, answer 1 comes from paragraph 4, and answer 2 came from paragraph 5. I think there was another one in here about melting waters releasing methane. Yeah, but we don't need that. Like carbon, methane stops some outgoing energy from leaving the Earth system. So really, we have our answer right here. Let's hand that in and go back to our slideshow. So we used our annotations to help answer the questions, and we hit the hand in button. Make sure to do that. There's also a link if you didn't get it the first time or you needed to go back and get those questions answered. So we now know how carbon dioxide and methane affect energy entering or exiting. It keeps the energy that would have left the Earth system. It redirects that energy and reflects it back to the surface. So it's like wrapping the entire Earth in a big giant blanket, not letting the energy or the heat leave the Earth system back out into space. Now, I think we'll probably be doing some investigations into that. This slide and the next few slides summarize key points from the article. Energy enters the Earth system from the sun. Then it either gets absorbed by Earth's surface or it leaves the Earth system by traveling back through the atmosphere and out to space. When more energy enters the Earth system than exits, the global temperatures increase. And you can see the bigger pipe is the one coming into the tank, not the one leaving the tank. So in that model of the orange water in the tank, this is the valve that's more open, which is filling the tank. And this one isn't letting enough water leave in that water model. The energy works the same way. When less energy enters the Earth system than exits, if this gets shut down, then the global temperatures will decrease. Now, carbon dioxide and methane affect energy exiting because they stop some outgoing energy from leaving the Earth system, which it normally would do. When carbon dioxide or methane increases, the amount of energy leaving the Earth system decreases. So it's like turning and shutting the valve that lets the water out of the tank of orange water. So that model comes back as a visual for this. More energy enters than exits, causing global average temperatures to increase. Or in the orange water tank, it would cause the tank to start filling up if you close the exit. You'll now use what you've learned about climate change in the Eocene to model what is causing our current climate change. So the before change panel shows that Earth, what it was like with less gas and lower temperatures, and the after change panel shows the Earth system with more gas and increased temperatures. So we're going to use the digital modeling tool. We're going to drag arrows for energy coming in to show how much energy is entering compared with how much energy is exiting. I think we'll also come in and put these, the pieces that aren't there. It says complete the model, so we'll use the pieces and address those to show why the temperature increases when the amount of carbon dioxide or methane increases. And don't forget to hit the hand in button. So here is our activity 3. It's opening up a new window. And now we get a chance to tell a more detailed story from our model here. In our last unit, we used paper models. In this one, we're using a digital version. So,
hello. Happy Teacher Appreciation.
All right.
We'll learn tomorrow.
Okay.
All right.
Appreciate that.
You're welcome.
Yes. Guys and girls, I just got, when I get back on camera, I'll show you what I just got. It's pretty awesome. So let's launch this tool, carbon dioxide and methane. There was a link in the activity 3. So we have the Eocene period. That's what we're thinking about. Before the Eocene period and during the Eocene period. Okay, so we have an idea here. Looks like a pretty good idea. We can reset at any time. We can undo anything. I think you can, when you drag it off the screen and put it back over here, it disappears. So there's all sorts of ways to make this work. It's pretty handy. But here's something in balance. Well, over here, we have something that's out of balance. The temperature right here is nice and normal, somewhere in between. Let's see what they call it. It's medium. So we have a medium temperature before, and with temperature increasing going to high, how did it do that? Did more energy come in? No, the sun stays the same. So the energy was equal. But the sun, here it is. The sun does stay the same. So that arrow, hang on a second. That arrow looks bigger than that arrow. But the sun didn't increase in energy, so we can't use that. Less energy entered than exited. That would mean that this would be getting colder if more energy left our system. So we don't want that. We have to use this one. This is the only one that makes sense. Although I differ, I would make this arrow the same as the sun, because this would imply the sun's getting hotter, but it's not, guys. There isn't more energy coming from the sun. It's the same amount. It's this one that's smaller. And that's the big idea right there, is that that's small. Ha! The big idea is that that's smaller. Ha! Okay, so what made it smaller? Well, some of these, right? And can we put some of these in there too? No, we can't, but more methane. Now, we could do carbon dioxide also, because this says or methane. Well, before this, there was a lot less methane. Maybe not that less methane, but a medium amount of methane. So really, this starts to look like the same kind of model we just drew digitally in chapter 1. Now, we do have to put the energy amounts in here, and I would use high for the after change. And before the change, when temperatures were stable, I would use the medium energy here, and you can kind of see the difference in the shade of energy at the surface. So we have a chance, we have our ice as part of our model. We have the energy absorbed, the temperature, and one particular gas. So we'll hand that in. That should send that as an upload. Yep. And we'll go back to our tab and see what else there is to do. So there's our model. Explain what your model shows. This model shows that methane keeps energy from leaving the Earth's system by redirecting the energy back to the surface as the energy tries to leave or tries to exit. This model shows that methane keeps energy from leaving the Earth system by redirecting the energy back to the surface as the energy tries to exit. It doesn't absorb the energy, it redirects it back. Well, it's interesting that in the article, it says that the sunlight passes right through the carbon dioxide molecules and the methane molecules. So something happens to the energy, the type of energy that leaves the Earth system must be a different kind of energy, because the explanation here says the amount of energy coming into the system from the sun wouldn't have changed because incoming sunlight passes right through carbon dioxide. However, carbon dioxide in the atmosphere stops some outgoing energy from leaving the Earth's system. Doesn't say that it redirects it, but I bet you when we go back to the sim next time, we'll see that. We'll update this. Let's make sure in the next one, in the next activity, activity 3, that we've hit the hand in button. There's our update. Let's go back and see if we're done with our slideshow. If there's an increase in the amount of carbon dioxide or methane, the amount of energy leaving the Earth system decreases, so more energy enters than exits. Our next lesson is going to tell us how that happens in detail. We've been focusing a lot on what causes the energy on the Earth system and temperature to increase. The opposite is also true. A decrease in carbon dioxide and methane can cause less energy in this system and lower the temperatures. If there's a decrease in the amount of carbon dioxide or methane, the amount of energy leaving the Earth system increases, so less energy enters than exits. More energy can exit because those molecules aren't redirecting that energy back to the surface. That's the end of our lesson, guys and girls. Now, as I've been looking through and my other classes, I'm finding that a lot of my chapter 1 material hasn't been submitted yet in those other classes that are here. I'm concerned about yours. So I'm going to be heading now into my 3rd period and be looking into chapter 1. Since this is now the 3rd lesson in chapter 2, you can see how far behind I am on giving you feedback on how well you did in chapter 1. And that is if you've done things in chapter 1. And I know a lot of you have, but I also know about half of you haven't. So once again, I'll be going in and putting those grades in so that they can either add to your other missing assignments. But please, guys, let me know. I haven't heard from 3rd period in days, and the grade average for the class is really falling. I really appreciate those that turn in their work every day, and I know there's a handful of you, and because of that, we're keeping this class above water. I really appreciate all of you that are willing to row this lifeboat through the end of the year. Keep doing what you're doing, guys and girls. If you're doing work, and if you're not doing science work, it's time to get busy. So I'm going to let you go. You have my permission. I'm going to stop recording in a moment. I'm not going to hit the end button and kick you guys out like I did yesterday. That was my bad. I hit the wrong button. So I do owe you an apology for that. It was kind of funny, but I'm sure that you took it for what it was, unintended accident from an old guy. I had a senior moment. So bye, folks. You have my permission to go. I hope you made progress today. I'll be uploading this video, and I'll be talking to you guys later.